Okay, the last section of this chapter is now going to deal with the law of cosines. Okay, and the law of cosines has three different scenarios, very similar to those area formulas I gave you yesterday, where it was the scenario that fit our information. Okay, it's to help you find one of the missing pieces. So if you have the three scenarios, the first one is a squared is going to be equal to b squared plus c squared minus 2bc times the cosine of angle A. That's the first scenario. So what will happen with this is that they'll give you things like, they'll give you a B, they'll give you a C, and then they'll give you angle A. So then you would use this in order to find little a, and once you find little a, then you can use the law of sines to figure out the other two. Okay? The second scenario deals with finding B. That would take the a squared plus the c squared minus 2ac times the cosine of big B. In the last scenario, c squared is going to equal the a squared plus b squared minus 2ab times the cosine of big C. Okay, so when you're looking at the law of cosines, the three different scenarios, notice how if it's little a here, then it's big A here, little b, big B, and so on. Okay, basically it's going to give you two of the things at an angle, but the angle is not going to match or pair with the other sides. It's going to be in the different part. Like it'll give you big A, little b, little c, so it won't give you ones that have matching, so I can't use the law of sines like I did yesterday. Not yet, anyway. So what I do is I put the information in that I'm given, find the little one that matches the big angle, and then I can use the law of sines after that. Because the law of sines goes a lot faster than this technique. Okay? So those are the three different scenarios. It's going to give you enough pieces to use one of those three. You do not need to use all three at one time. You just have to use the one that matches our situation. Does that make sense? Okay? So, if in you go to page 892, this is what it's going to give you. It's going to give you angle A is equal to 103 degrees. Little b is equal to 15. Little c is equal to 24. You are supposed to find little a, big B, big C. Just like you were for today. Everything about it's the same except for now. Notice how I don't have the same, like I don't have both A's. And I don't have both B's, I don't have both C's like I did yesterday, so therefore I could use the law of sines. So now this is where we use the law of cosines in order to find one of those. Okay, and how you do that is you find the missing side. Because you're only given one angle, and that angle does not pair with one of those other two. So we're going to find the missing side. So which one of those three scenarios that I give you that we're going to use for the cosine? The first one. Right. So we're going to set this up like this. A squared equals b squared, which is 15, plus c squared, which is 24, minus 2 times 15, which is b, times 24, which is c, times the cosine of the big A. Your calculator is going to get a workout today. Does anybody know what 15 squared is? 225. Anybody know what 24 squared is? 576. Minus whatever that junk is. Right? That's going to be a mess. Shouldn't be it shouldn't be a whole number because we got cosine in there. Okay? I'm already going to stop Denise right now because she's already screwing this part up. And I don't want everybody else to do that too. Okay? Do not get this plus this minus this number times by the cosine of 103. order of operations, right? Exponents first. That's why I asked you for those two. Then I said that this is one big mess because this is all times. I just ran out of space. This should be one giant decimal, shouldn't it? Because the cosine of 103 ain't going to come out to be a whole number. So 225 plus 576, you could do that if you really wanted to. And then minus out the back end. I don't know what the decimal is, nor do I really want to know. How would you find just regular A if it's A squared? Right, I'm going to square root both sides, and I'm going to square root all that mess. So that okay, so you see what I was saying with that one? Right? Yeah, or 720. Did you see what you were doing wrong? Okay, good. Anybody get A yet? Huh? What you have to do on this one, Noah, is you got to take the square root of 225 plus 576 minus 720 times the cosine of 103. 31? Is that rounded?
Yeah.
Got to be, right? It's 31.0?
Yeah, 30.0.
Okay, well, so 31. All right. Thanks, Val. So on my calculator, I should have typed the square root 225, or better yet, could you type in 15 squared if you really wanted to? Could you even back it all up instead of chunking it and getting all those pieces? Couldn't you just type the whole thing in at one time? Yes, you can. Plus, well, let's write it that way then. So 15 squared plus 24 squared minus 2 times 15 times 24 cosine of 103. You'll have to probably double shot it at the end because when it does that square root thing, it automatically comes up with a parenthesis on the older ones. On the newer ones, it'll just continue to carry out, right? And we got 31. A lot of you got that, and if you didn't, I'll help you. Probably just type something.
What did you change on it?
I changed your mode into degrees.
Okay, that would probably help a lot.
Yeah, because what was happening is, and if you were getting other numbers from us the whole time,
yeah,
it's because you were in radian measure.
Okay.
And when we're putting that 103, we put that in there as a degree.
Okay.
So it needs to be in degree mode.
Cool.
So, okay, so now that I got the 31, do you guys really want to find angle B by using the law of cosines and having to work backwards out of that? Or would you much rather just use like the law of sines, where we cross multiplied and divided? Me too. And that's more user friendly. So I'm going to take the sine of 103 over 31, because that's what we just found for that one now, equals the sine of B over 15. And on that particular thing then, after you cross multiply and you find the inverse sine of it.
Is that right?
Yeah.
All right.
That's what I put right here, 31.
Okay. Got it.
Yeah, good job. So when I cross multiply and I divide, I got to have 15, or the inverse sine. 15 sine of 103 divided by 31. That should be in there. What was it? 28 degrees? Or 28.1? Did anybody else get that? Couple? Okay, good. Now, Alyssa, because I know you know what to do now, if I want to find the third angle, how are you going to find it?
You have to add both A and B together and subtract 150.
Awesome. Nice job. So 180 minus 103 minus 28.1 gives us what? And done. That was number 12, by the way. Okay. Is it a lot like yesterday? Only the difference is I got to use one other formula before I use the law of sines. It is exactly like yesterday. On 14. Little a is 38. Little b is 31. Little c is 35. It doesn't give you an angle at all, people. So now, this is where it becomes your choice. Do you want to find big A, big B, or big C? Either way, we're going to have to use the law of cosines, but it's your choice on which one you find first. I don't care. Big B? Okay. So if we're going to find big B first, bless you, Marco, then we're going to put the B in the front, so that's 31 squared equals the A squared, so 38 squared, plus the C, which is 35 squared, minus 2 times 38 times 35 times the cosine, yuck, a cosine of big B. Okay, I need to know some numbers from you guys. I don't know what 31 squared is. How much? 961. I don't know what 38 squared is. 1,000 what? I don't know what 35 squared is. Can someone do 2 times 38 times 35 for me? 2,660. Now, your job on this one, we need to find and get B by itself. That's what we need to do. We're solving an equation that you guys have solved since like the 7th and 8th grade. How do I get rid of adding? Subtract it over. So what you're going to do is you're going to take 961 minus 1444 and minus 1225. Yes, it should be a negative. What is 961 minus those two numbers? Like that? Okay? Now, to get the cosine of B all by itself, how do you get rid of divide? Or times? Divide. And I should get some crazy decimal looking thing, right? But it's going to be positive, isn't it? What is it? 0.64. Blah, 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 blah. Okay? Now, how do you find the angle? Inverse of which one? Cosine. Good job. If I inverse cosine that number, so if I go like this, and if you have your TI stuff, here's how you could do it. You could go inverse cosine, and then if you hit second and the negative button, that gives you the previous answer in that spot. It'll say ANS. Instead of retyping it if you want to. Well, don't do it now because that will give you that answer would be put in there. But what angle did I get?
50.1.
How much?
50.1.
And that was angle B, right? As soon as you know one angle, now what are you going to do? Law of sines. Which one? Big A or big C? Huh? Big A? So I got big A, or sine of big A, over 38 equals the sine of 50.1 divided by 31. After I cross multiply and divide, I get 38 times the sine of 50.1 divided by 31. Inverse sine of all that. And that should give me the angle. Just like what I did for today. What do you get? How much?
70.1.
70.1. Once you have two angles, Liz, how do you find the third? Yeah. What's 180 minus 70.1 minus 50.1? 59.8. Now, we've talked about this before the last couple days, but I want to make sure you guys are aware of this. Did you notice that the shorter side yielded the smallest angle? Medium side, medium angle. Big side, big angle, as it should have. If it didn't work out that way, you screwed up somehow. Okay? That was 14. So some of the times they'll give you an angle, and then you got to use it to find the missing side, and sometimes it'll give you all three sides. So you got to work backwards. It's solving an equation. Okay? The last set of things that I'm going to give you is another formula for area. And this one's using what we call Heron's formula. And how it works to find Heron's formula, or to use the triangle, you take the square root of S minus A, S minus B, S minus C. And S is found by doing this. You take A plus B plus C and divide it by 2. That's how you find S. Huh? Yeah, well, kind of. But see, with the average, we would have been dividing by 3, not 2. Okay? So, here's what they're going to give you. It's going to say A equals 12, B equals 7, C equals 8. So the first thing I need you to do is add those numbers together. What is 12 plus 7 plus 8? Then I need you to take that and divide it by 2. 13 and a half. Now, when you're using Heron's formula, 13.5 needs to be in there first, all by its lonesome. And that's what a lot of people forget when they're setting it up. They forget that that one needs to be in there all by itself. Then you need to take 13.5 minus each of the sides. Minus 12, 13.5 minus 7. Oops, forgot to put the minus sign. And 13.5 minus 8. Quick question for all of you with calculators and graphing wise and all that kind of stuff. Or even their non-scientific ones that you can use and like what Taylor's got. Can I just put that whole thing in the calculator as is? and hit enter when I get done with it, instead of actually subtracting 13.5 minus 12 and get 1.5 and so on? I can, right? Okay, good. What do I get? $26.1? So my answer is 26.9. And now, it didn't have a units, so I just leave it as 26.9. That's how you do the last half of your assignment. You have to add all the three sides together first, which they will give you all the sides. Divide it by 2, and then put it in that formula that way, and you're done. Do you want to do another one of those? Okay. If not, then on that page 892 to 893, you know what? I'm going to do this instead. I was supposed to be evens, but I'm just going to give you multiples of 4. Only because it was such a lot of work.